Good morning, myself I'm R. Akshaya. I'm from CSIT branch. Today my Tech Talk topic is a look at the design of Lua. Introduction to Lua. Lua is an open source language built on top of C programming language. Lua has its value across multiple platforms ranging from large server systems to small mobile applications. This tutorial covers various topics ranging from the basics of Lua to its scope in various applications. Lua is an extensible lightweight programming language written in C. It started as an in-house project in 1993 by Roberto Leruslamsi, Luis Henrik D. Figueroa and Vladimir Xilis. It was designed from the beginning to be a software that can be integrated with the code written in C and other conventional languages. This integration brings many benefits. It does not try to do what C can already do, but aims at offering what C is not good at. A good distance from the hardware, dynamic structures, no redundancies, ease of testing and debugging. For this, Lua has a safe environment, automatic memory management, and good facilities for handling strings and other kinds of data with dynamic size. Features of Lua. Lua provides a set of unique features that makes it distinct from other languages. These includes extensible, simple, efficient, portable, free, and open. How Lua is implemented. Lua consists of two parts, the Lua interpreter part and the functioning software system. The functioning software system is an actual computer application that can interpret programs written in the Lua programming language. The Lua interpreter is written in ANSI C, hence it is highly portable and can run on a vast spectrum of devices from high-end network servers to small devices. Both Lua's language and its interpreter are mature, small, and fast. It has evolved from other programming languages and top software standards. Being small in size makes it possible for it to run on small devices with low memory. Learning Lua. The most important point while learning Lua is to focus on the concepts without getting lost in its technical details. The purpose of learning a programming language is to become a better programmer. That is, to become more effective in designing and implementing new systems and at maintaining old ones. Some uses of Lua. Game programming. Second one, scripting in standalone applications. Third, scripting in web. Fourth, extensions and add-ons for databases like MySQL Proxy and MySQL Workbench. Fifth, security systems like intrusion detection system. This is a diagram or representation of Lua. Design of Lua. Lua is a scripting language developed at the Pontifical Catholic University of Rio de Janeiro that has come to the leading scripting language for video games worldwide. It is also used extensively in embedded devices like set-top boxes and TVs and in other applications like Adobe Photoshop, Lightroom and Wikipedia. Its first version was released in 1993. The current version Lua 5.3 was released in 2015. Though mainly a procedural language, Lua lends itself to several other paradigms including object-oriented programming, functional programming and data-driven programming. It also offers good support for data description. It is a style of JavaScript and JSON. Data description was indeed one of our main motivations for creating Lua, some years before the appearance of XML and JavaScript. Our motto in the design of Lua has always been mechanisms instead of policies. By policy, we mean a methodological way of using existing mechanisms to build a new abstraction. Encapsulation in the C language provides a good example of a policy. The ISO C specification offers no mechanism for modules or interfaces. Nevertheless, C programmers leverage existing mechanisms such as file inclusion and external declarations to achieve those abstractions. On top of such basic mechanisms provided by the C language, policy adds several rules such as all global functions should have prototype in a header file, and header files should not define objects, only declare them. Many programmers do not know these rules, and the policy as a whole are not part of the C language. Accordingly, in the design of Lua, we have replaced addition of many different features by creating instead only a few mechanisms that only programmers to implement such features themselves. The motto leads to a design that is economical in concepts. Lua offers exactly one general mechanism for each major aspect of programming: tables for data, functions for abstraction, and coroutines for control. On top of these building blocks, programmers implement several other features, including modules and objects and environments, with the aid of minimal additions, such as syntactic sugar to the language. Here we look at how this motto has worked out in the design of Lua. Design goals. Like other scripting languages, Lua has dynamic types, dynamic data structures, garbage collection, and an eval-like functionality. Consider Lua's particular set of goals. First is simplicity. Lua aims to offer only a few powerful mechanisms that can address several different needs. Instead of myriad specific language constructs, each tailored for a specific need. The Lua reference manual is small with approximately 100 pages covering the language, its standard libraries, and the API with C. The second includes small size. The entire implementation of Lua consists of 25,000 lines of C code. The binary for 64 Linux has 200k bytes. Being small is important for both portability, as Lua must fit into a system before running there, and embedding, as it should not bloat the host application that embeds it. Third includes portability. Lua is implemented in ISO-C and runs in virtually any system with as little as 300k bytes of memory. Lua runs in all mainstream systems and also on mainframes inside OS kernels such as NetBSD kernel, and on bare metal such as Node MCU running on the ESP8266 microcontroller. And the final one includes embeddability. Lua was designed since its inception to interoperate with other languages, both by extending allowing Lua code to call functions written in a foreign language and by embedding allowing foreign code to call functions written in Lua. Lua is thus implemented not as a standalone program but as a library with a C API. This library exports functions that create a new Lua state, load code into a state, call functions loaded into a state, access global variables in a state, and perform other basic tasks. The standalone Lua interpreter is a tiny application written on top of the library. These goals have had a deep impact on our design of Lua. Portability restricts what the standard libraries can offer to what is available in ISO-C, including date and time, file and string manipulation, and basic mathematical functions. Everything else must be provided by external libraries. Lua favors mechanisms that can be represented naturally in a Lua C API. For instance, Lua tries to avoid or reduce the use of special syntax for a new mechanism. Following the motto, mechanisms instead of policies had a clear impact on simplicity and large size. The first 5 are no surprise, the last 3 give Lua its flavor and are the ones we discuss here. However, given the importance of embeddability in the design of Lua, we first briefly introduce the interface between Lua and its host language. Lua environment, local environment setup. If you are still willing to set up your environment for Lua programming language, you need the following software available on your computer: text editor, the Lua interpreter, and the Lua compiler. Text editor. The files you create with your editor are called source files, and these files contain the program source code. The source files for Lua programs are typically named with the extension .lua. And examples of few editors include Windows Notepad, OS Edit Command, Brief, Epsilon, Emacs, and Vim or Vi. The Lua interpreter. It is just a small program that enables you to type Lua commands and have them executed immediately. It stops the execution of Lua file in case it encounters an error, unlike the compiler that executes fully. The Lua compiler. When we extend Lua to other languages or applications, we need a software development kit with a compiler that is compatible with the Lua application program interface. Installation on Windows. There is a separate IDE named SCITE developed for the Windows environment, which can be developed from the following link. Run the downloaded executable to install the Lua IDE. Since it is an IDE, you can both create and build the Lua code using the same. Installation on Linux. To download and build Lua, use the following commands. In order to install on other platforms like AX, ANSI, BSD, generic Linux, MINGW, POSIX, Solaris by replacing Linux. In Make Linux, test with the corresponding platform name. Now we can build a run and Lua file, say hello world.lua, by switching to the folder containing the file using cd and then using the following command. Thank you.